let me begin with this new topic on introduction of high-speed track in Indian Railways. First of all, we should know what is a high-speed track. We hear a lot many times high-speed track. But what is a high-speed track? Yes, anyone? What is high-speed track? Where speed is more than 250 kmph. So what we are planning today, that is 160 and 200 kmph, etc. That is not a high-speed track. As per UIC definition of high speed, any speed of train running more than 250 kmph or 250, that is called as a high-speed track. So this Ahmedabad Mumbai section, what we are planning is to run the train at 350 kmph. Okay, everything is being designed for a speed of 350 kmph, and idea is to compete with air transport. So Ahmedabad, Mumbai, what we have today, let us say trains are taking about 7 to 8 hours or whatever, that we want to reduce it to maybe 2 hours or 2.5 hours. And the planning is to run these trains in peak hours at every 30 minutes. And so that passenger come to the station, they board the train, and in another 2 hours or so, they reach to the destination. So that is the idea. Of course, in the beginning, there was a lot of criticism, as usual by oppositions, and that criticism, I think, still some of them have. And you will be surprised to know that when this Delhi Metro was introduced, the construction of Delhi Metro, that time also there was criticism saying that India is a poor country. Why to invest that much of money in these kinds of metro rails, Delhi Metro? But now the situation is most of the big cities, they are demanding metro rail, and construction is going on in full swing. Okay, not these 4 metros, but other cities also. So the result of this construction for high-speed track, we will come to know only once it is constructed and trains start plying on it. Then only we will see the fruits. But as of today, the work on Ahmedabad Mumbai section is already started. What I got information from the concerned person, that contract for almost 50% of the work have already been awarded. The rest are in pipeline, and work is in different phases of construction. Right. So let us see some features of Ahmedabad Mumbai speed corridor. Total length is 534 kilometer. This is a combination of elevated and on formation and tunnels. Elevated means construction of viaducts. The design of entire patch is by Japanese agency, that is JICA. It will be mostly concrete roadbed and slab track. Concrete roadbed and slab track, whether it is elevated or on formation. The target speed 350 kmph, cost about 1 lakh crore, which may be slightly here and there depending on the time. Train frequency in peak hours, it is every 20 minute what they can accommodate. What they can accommodate is in their system at every 20 minute a train can ply. This is the maximum capacity that they have targeted. But in beginning, probably this will not be the frequency. Of course, what has been stated by MD High Speed Corridor, that they are planning to run at every 30 minutes in peak hours, and then in non-peak hours it may run at every 1 hour or maybe every 2 hours. So that is the planning. Now, requirement of high-speed road in regard to track, it is track structure and geometry, then formation, wherever we are constructing it on formation, rolling stock, advanced electrification and signaling system, advanced operating system, and of course we need to introduce advanced maintenance system also. So let us see one by one. Track structure and geometry. In entire construction, the sharpest degree of curvature is only 0.5 degree. Sharpest means anywhere in entire section, so it is 0.5 degree. Otherwise, mostly it is straight or less than 0.5. This is that section of slab and track. I just give you 2 minutes time to see this item here. Let me make it slightly bigger. See this first section. This is for curved track. The first one you see is for curved track. Okay. This is a side drain here, then followed by formation and another drain here, this side. So first it says the compacted bed here, and over the compacted bed, then you have a concrete road bed. Okay. So one by one, if you see all components from bottom to top, the section or the structure for entire construction, you will be able to appreciate that how sturdy and strong they are making it. So first let us see, this is rail. Then below rail you have track slab. This is precast track slab, the green one. And below this track slab, then you have cement asphalt mortar to provide a cushion. The cement asphalt mortar will provide a cushion and also facilitate some corrections to cross levels, etc. Then below this cement asphalt mortar, then you have reinforced concrete bed. And the requirement of super elevation for this high speed, etc. is taken care in this RCC road bed. You can see whatever super elevation was required as per the degree of curvature of your mainline curve, that super elevation is provided here in RCC road bed. Okay. Now below this RCC road bed, then we have lean concrete bed. This is lean concrete bed. This layer, where my cursor is moving, this is your lean concrete bed. So RCC bed, then below is lean concrete bed. Here also some reinforcement is provided to take care of thermal expansions, and below this ordinary concrete bed, you can see you have compacted crushed stone and sand filling to be done in layers. That is the formation normally we provide in our railway track.
Sir, one doubt.
Yes, please.
Sir, that is a lean concrete, but when it is having the reinforcement,
yes,
there is a chance of corrosion.
Corrosion. No, see, if
lean,
you take,
because it is lean.
The lean means it is not that lean. We will see in detail. It is not that lean. Okay. It is not that lean. We will see in detail. Lean in terms of the upper layer, that is RCC concrete track bed. Okay. They have provided proper reinforcement in this below concrete road bed also. We will see. First, just try to understand layer by layer this structure. Okay. So top one is precast concrete slab. Below it is cement asphalt mortar. Then they have RCC concrete track bed. Below it they have another concrete bed. Let me not call it as a lean concrete bed. This is a concrete road bed. And the slope in formation is provided in this lower part of concrete road bed. And below it we have compacted formation. Compacted formation, what we construct for our railway track. So this is how the structure is created. And for curved track, the super elevation is provided in the upper RCC concrete road bed. And if it is straight plain track, no super elevation, the structure will look like as you can see on the right side. Okay. So this is a shape or a structure for high speed track, whether it is curved track or straight track. This is just a sample, and this sample or model has already been created at Baroda near our Nair Institute, because high speed office is located near Nair Institute. So they have created this sample or model track structure both for curve and for straight. If somebody happens to visit to Nair, please see this track structure already available there. Okay. So this is the general arrangement of different, say, component of only track. Now this is a simple one view of precast slab, where my cursor is running here. You can see these are the precast slab and rails fixed on precast slab. Okay. All the construction on formation has been done, and here you can see this arrangement. This is that RCC concrete road bed, not the below wala. This is RCC concrete road bed. Over it you have cement asphalt mortar, and then precast concrete slab. This is precast concrete slab, and over it you have rail and fastenings. Okay. This round shaped structure, which is called as a bollard, this round shaped structure is part of this RCC concrete road bed. This round shaped structure is part of this RCC concrete road bed, and this round shaped structure acts in two ways. One, to provide a clear separation gap between one precast slab to the other precast slab. Secondly, it also the lateral or longitudinal disturbances of this precast bed slab. We will see. Now this is a slab track plan, I think it is very difficult to make out from such a small figure. But here you have only, let us see, these are the dimensions, how they are arranged. So 625 center to center spacing, and the total length, it is approximately 4900 millimeter. That means about 5, each slab is 5 meters. So each slab is 5 meters, and one slab is separated by the slab through these circular bollard. Okay, and in between you have this gap available not only to economize but also to facilitate lifting, etc. during handling. Okay, so this is the top plan of your slab track, and now you see the step-by-step construction, what they have done to create a model track structure in Baroda. The same photos I have got from them. You see, if you move from here, this is before site clearance, first figure. Then second figure, site clearance in progress. Then crushed stone filling. That means creating a formation. So here in third, they are, sorry, this is third. I'm sorry. This one is third. Excavation is going on. And after excavation, then preparation of formation. And you can see this is backfilling, creating a formation. Then next is, now we have reached up to top of formation. Okay, and as in our case, in our construction, we check by CBR value, etc. regarding the construction quality and its capability, etc. We check by CBR value. In Japan or by JICA, they check by so-called as a K30 value. Okay, this is called as a K30 value, but it is similar to our CBR value. So they ensure with this K30 value so that the formation top is properly compacted and properly constructed. Okay, so this is how now the top of formation is created. Now after top of formation, then this is bottom wala concrete. You can see the reinforcement. So this is called as a wire mesh placing on top of reinforcement, on top of embankment, and then the bottom wala concrete bed. So reinforcement is provided in this concrete bed, and this is not lean. In fact, I just mentioned lean as compared to the top wala, but it is proper concrete 1:2:4 wala. So proper concrete road bed is in progress with reinforcement. So this is that concrete bottom wala concrete bed. You can see the slope, etc. has been provided here both sides in bottom wala concrete bed as we saw in initial cross section, and this is final finishing. Okay, so finally bottom wala concrete is road bed is constructed, and this is without any cant, because cant, etc. has to be given on top wala concrete bed. Then comes construction of top concrete bed. It's still concrete road bed. So concrete road bed, top wala, we provide reinforcement, proper reinforcement as per design requirement, so that it is capable of taking all those viability dynamic loads. And then these bollards, you see, this is created to make that bollard where you provide a separation between one slab to the other slab, and taking out slab and putting that slab is also becoming easy here if you provide this kind of a structure. So this is that top concrete bed. And finally you can see bottom wala here. This is bottom wala. Okay. And over it you have this top wala. Now here, because they were creating a model type of track structure, so on one side this is a plane without any super elevation, on other side they have created with super elevation, whatever was required as per design. Okay, so this is finally the constructed road bed. Still precast slabs have not come over it. So you have formation, then one layer of concrete bed, that is also RCC, of course lean RCC, and then you have proper RCC road bed. Now over it will come your precast slab, and these are the precast slab. These precast slabs will be constructed in a different place, in a controlled manner, where you have all facilities of controlling the quality, and then they will be transported to the site and placed on top of top concrete bed. Of course, in between there will be a layer of cement, mortar, asphalt. Okay, so this is the construction from bottom to top. Now here, they are showing how the cement, mortar, asphalt is placed between the top precast slab and the top of concrete bed. Okay, so for this they have a machine which, with the help of hydraulic pressure, they fill up the bags, and these bags are laid between the slab and the top of concrete bed. And whatever little corrections whenever they required, those corrections and levels, etc. can be done with the help of this cement asphalt mortar. Okay, cement mortar asphalt. So this is how it is done. And finally, when slab is placed, you see this layer of CA mortar, okay, filled in proper bags. And this provides cushion and also helps in slight, I again repeat, slight modifications in level. Why slight? क्योंकि आप बहुत ज्यादा इसमें deteriorate होने का चांस रहता है, because you are taking all precautions. Whatever you construct, that should be perfect. तो construction quality ही इसकी इतनी अच्छी होनी है कि right from beginning you have all parameters very in a perfect condition. Okay, so this is how they go about. Then inserts and fasteners, they are similar to what Japan has used in their system of high-speed track. They are like this. You can see one by one. T-headed bolts, rubber pad, adjustable pad, bolt. So all this arrangement where Japanese railways are using the same way we are going to use in our Ahmedabad-Mumbai high-speed section. Okay, just have a look. Then how this manufacturing of track slab is done. This is a complete cycle. You can see from number 1, 2, 3, 4, 5. So let us say we start from item number 2. After complete formation of slab, when it is constructed, we remove the formwork and take it for curing, etc. Here item number 3, it is taken out, being taken to required place. This is the formwork. After this is taken out, formwork is ready for another casting of slab. And whatever reinforcement is required is placed in this formwork. This is here in item number 6. After placing reinforcement and proper checking, etc., then concrete is poured. Then after concrete pouring, it is taken to steam curing. And after steam curing, it is taken to water curing. And thereafter, it is brought for taking out of this. In the meantime, you check the strength of concrete also, whether it is meeting the requirement or not. So this is 1 day cycle. Okay, this is 1 day cycle. How slowly, and most of the activities are mechanized, like opening of this formwork, opening, closing, etc. This is all mechanized. This opens in a hydraulic manner, like this is our formwork or mold. This is how it opens. You can say opening and placing of reinforcement and inserts, etc. for fitting the rails. That is that reinforcement cage ready to be lifted and put up. This reinforcement cage is prepared outside, not within that formwork. This is prepared to the dimension. This is prepared outside and then lifted and placed on top of mold. And finally, it is placed on top of mold. Then mold refixed. Checking of reinforcement, etc. is done. This is that checking. Before concreting, before pouring concrete, this proper checking is done. And then concrete is poured. With the use of surface vibrators, compaction is ensured. And finally, finishing the top surface. And after that, it is taken for steam curing. In steam curing, it is a controlled kind of curing. Slowly the temperature is raised and then again brought down. And you can see the total time it takes about, say, 10 hours or so. And thereafter, it is taken to water curing. And in water curing, it is kept for about 7 to 8 days because steam curing is done, or maybe slightly more. And thereafter, it is taken out for placement. This is that team. This gentleman is Mr. Anupam Awasthi, who is now posted in this high-speed corridor. He had gone to Japan for some 2 years course sent by railway. And after coming back from there, he has now been posted in high-speed corridor. So taking out this slab and finally checking, etc., inspection, and then ready for use after water curing. Okay, as regards to rail, the same 60 kg rail will be used, but these rail will be from Japan, not from India. Okay, all these rails will be transported from Japan and they will be used in this Ahmedabad-Mumbai corridor. They are being procured from Nippon Steel and Sumitomo Metal. Of course, there was a debate why not to use our own Indian rails, but ultimately for this project it has been agreed that they will be from Japan only. The entire technology is from Japan. There will be 2 sets, maintenance sets, one at Mehsana and one at Virar. As regards to funding, 80% by Japan government and 10% to be shared by state of Gujarat and Maharashtra, and 10% by railways. So 80% component is coming from Japan, 20% is being shared 50-50% by the central and state government. So Gujarat government 5% approximately, and Maharashtra government 5%, and remaining 10% by center. And we will pay royalty to Japan corresponding to this 80%. Something about signaling and operation. Signaling system will be high speed automatic traffic control system. As it is being done in other countries, it is already UIC accepted system, and this will ensure safe train of separation, the distance between the two trains, prevention of overspeed derailments. If somebody is overspeeding, it will automatically control and reduce their speed. Then fail-safe train detection. If there is anything or any obstruction in the track, it will fail on safer side. Broken rail detection system. So third wala is for detecting any obstruction, and fourth wala is detecting any broken rail. So whenever there is a fracture, the message of this fracture will be communicated to the nearest signal, and that signal will be brought to danger. So before train approaches this spot, the signaling is likely to take care of the train crossing this failed section. Okay, proper interlocking rule and hazard response and work zone protection. Okay, if somebody is working in track and train is approaching, so it will be able to detect that system also. Now it will work on these system ATP, ATO and ATS. ATP is nothing but automatic train protection, then automatic train operation and automatic train supervisor. Let us see one by one. This automatic train protection, basically automatic train protection, as we discussed, it takes care of any obstruction, it takes care of rail fracture and anybody working on track, impinging your track's circuiting system. Then the same message will be communicated to the controller and to the signal system. Automatic train operation means there will not be any controller to guide the movement of train. Of course, controllers will be there, but the operation will be governed by computerized system, and train will move as per this automatic train operation system. Similarly, automatic train supervisor, meaning wherever you have the requisite stops, the train will come to a stop even driver forgets to apply the brake. Okay, so the train stopping, etc., will be fed into the computer of the train, and it will come to a stop after covering that much of distance.